Hey everyone, this is Shashank Mishra, currently working as Data Engineer 3 at Expedia, and in today's video I will be talking about basics of SQL with its practical implementation. So before starting the video, if you are new to the channel, then make sure to hit the subscribe button and press the notification icon. Also, if you want to keep learning from leading industry experts, then make sure to check out Scalar's event page, link is in the description. So now let's get started. So to start with the basics of SQL, first we will try to set up the environment in our local machine, and to our implementation part we are going to use the widely used transactional database which is MySQL. So first let me show you how you can set up environment related to MySQL in your local machine, be it Windows, MacBook or any other laptop, desktop you are having. We can simply download it from the MySQL dev, this environment, and we can set it up very easily in just few steps. So what you need to do, you can open the web browser and simply type MySQL workbench, and after that you can mention your machine name directly if you have Windows or Mac, whatever it is, and simply click here, and after that you will see this link dev.mysql.com. Simply click on this URL and here it will redirect you on that respective machine environment you have, the operating system, and even you can select it directly from here. If you have Windows machine, you can simply toggle onto that option, and here it will provide you this option to download the respective jar files or any kind of libraries which can help you to set up this workbench. So I am using Mac OS, so I'll just click on here and then I will download this .dmg file. I can simply click on it, and here it will ask for the login or sign up. No need to do that. Simply click on this no thanks, just start my download option, and it will start downloading this package which we can see here. And once this download part is done, it's just all about the double click and that .dmg file will directly install this MySQL workbench in your system. So here as we can see, we have downloaded this one, and since this MySQL workbench is already installed in my system, no need to do that again. So I'll directly show you how you need to proceed on the MySQL workbench, how it looks like and how we can perform different operations. So let me go there. Cool. So after installing the MySQL workbench, it will look like this. Its environment, or it completely provides you the ID sort of environment where you can write your SQL commands. Also, once you will start setting up MySQL workbench in the local, it will ask you for root user and password, which you can set up accordingly, because this MySQL workbench also provides you MySQL instance, because this is a background service which needs to keep on running in the background. So as soon as you start the MySQL workbench from your machine, right, you need to provide the password, you need to provide the username, and then it will simply start it. And after that, this is how the interface will look like. And after that, I will guide you what are the meanings of these keywords which are written here, and what all operations we will be performing and how we will be performing. So first part is the databases. So when we talk about transactional databases or database management system, so MySQL is what? MySQL is actually a database management system which provides all those kind of environments where we can manipulate the data by using some query language, and typically used like the SQL. Okay. So first let me show you how we create the databases and what is the meaning of schemas here, so that you don't get confused, because the common keywords which are used across different databases, that is database itself, and there will be different databases where this keyword might get changed, like key space schema. So I don't want you to get confused with these terms. So in the MySQL workbench, the meaning of schema is very simple. It is just like creating a different folder inside this ID itself, and inside that one we are creating different databases. So that is the simple meaning, and you don't need to do any sort of custom settings here. As soon as you start exploring it, you can definitely tune those settings, but by default whatever interface it will provide, it's good to go. You can execute your SQL commands, queries, everything. So first and very basic thing, how we create the database in SQL, what's command we will be following. So the very basic thing you can see, right, these are the databases which I have already created for testing purpose, like DemoDB. Sys is something which comes by default, because this is what, this is a software itself. This is you can say workbench, or it needs to store some metadata, right? Whatever things we are creating, whatever commands we are executing, so some default tables, right, as a root user will be set up, which different user cannot delete, which different user cannot manipulate. All right, so similar thing we can see, these are the default databases like sys, but this DemoDB, test2, testdb, testdb1, this is something which I already created, but here we will create a fresh one. So what's the command for that one? Create database, and we can give a database name here. So for that one, first demo. Okay, so you might be wondering how to open this notepad sort of file here. So we can click on this one, this left option in this menu bar, right, plus symbol. So what it will do, it will open a new SQL file, like this is a blank file which you can see. All right, and this one which I already opened, and I have placed these placeholders so that we can follow a proper sequence of SQL commands, and you will be also able to relate it how these things are executing step by step. So create database, first demo, and now how to actually execute it. Okay, so just select this portion from here and click on this thunder kind of symbol. Okay, so if I click on it, then here in the logs you can see this log has been printed, how much time it has taken, or if it's a green check symbol, that means this command has been executed successfully. By chance, let's say this command was supposed to be failed, then we will also get a proper error message so that we can debug it and we can fix it. So here, since it's successful, right, now at this moment we are not able to see this database in this left panel. Okay, so what's the reason? Sometimes it needs to keep on refreshing itself. So what you can see this refresh symbol in front of this schemas keyword. So just click on it, and after that it is easily visible to you. This database has been created, first underscore demo. And if I expand it, then you can see multiple options are there: tables, views, stored procedures, functions. So this category is basically to provide a hierarchy in this ID itself, so that let's say we are creating few tables inside a database. As soon as we will create it, those will be visible here with the column names and its data type. All these kind of metadata information will be mentioned here. So after creating a database, we need to look at the command that how to use it, because different tables will be created inside different databases. So what's the command to go inside a database? For that one, we can write use database, and here we need to mention our database name itself. No need to use any database keyword, simply use and mention the database name. And if I execute it, right, this command is also successful. Now we are inside the first demo database, and if you have observed, there are multiple databases, but when I clicked on it, when I executed it, this is something which is now focus area, right, the bold section on the ID itself. So this is the cool part, I would definitely say. Now we have created a database, we have seen the command how to use it. Let's look at how to drop a database as well. Dropping a database, let's say earlier we were doing some stuff for our testing or development. Now that database is not in use, how to actually delete it completely. Okay, so for that one we can use the command drop database and database name. Okay, if I execute this one, so since I have created this fresh database, I don't want to delete it. What I can do for my testing purpose, I can delete any existing database. Let's say I am trying to delete test_2, which I created previously. So test_2, let's execute it. Okay, now you can see this is also successful, and as soon as I execute it, it is removed from this left panel as well. All right, so the database creation part is done. Now we will move that how to create the tables inside a database. Okay, we created it, we used, now we are actually inside our first demo database. So this is the command to create a table in the database. These are the keywords which we actually need to follow, like create table. Okay, and after that we need to mention our table name. So each table in these kind of transactional databases is like a row columnar sort of data. Okay, so column name just like a variable which will have its own specific data type. So when we create the tables in MySQL databases, we need to provide few informations. So if you look at this entire command, this is a command we will be using to create a table. So after providing the table name, inside the parentheses, these parentheses, we are mentioning different column names, right? And after that we are mentioning the data type. Then we are mentioning few keywords which you might be wondering what is that and what is the reason to use these things. For example, not null, right? Then this is the keyword default. Okay, and this is another keyword, primary key. So let's try to understand one by one what kind of sequence we need to follow. So first we need to mention the column name, and after that we need to mention the data type. So different type of data types available in MySQL database. If some column which is supposed to hold the string type of value, it should be named like this, varchar. So when we define the data type as varchar, so by default it will pick some length, but if we want to customize this length, for example this particular column will hardly take 10 characters, so we can simply mention this thing, right? And let's suppose we have different data types, for example integer values, float values, double values, the date type of columns. So those type of data types are also available. Next thing, these are the keywords actually used to define the integrity constraints. So when we talk about the transactional databases, one of the important property is the consistency part, and we can keep the things consistent when we apply some rules, and that is something which is known as the integrity constraints in the transactional databases. And I have created a similar video on Scalar's YouTube channel related to this topic, and it's a long video where I have covered all the database management related fundamentals, so you can check that video here. So talking about the integrity constraint, not null and default is another type of integrity constraint. Let's say you have defined a column, and while inserting the values, let's say somebody is inserting null value, okay, and value is actually missing from that insert command. So by default we don't want to keep this column empty. So what we will try to mention some default values, so that if somebody is providing null sort of values, this value will be populated with that particular default value. That is the reason of this integrity constraint. And similarly you can see not null is something which has been used multiple times. So this constraint will prevent any kind of insert command which is trying to insert the null values, and that is the reason these rules keeps our database tables properly consistent. This keyword is something which is very much important. when we talk about the transactional databases, the concept of keys is super duper important, and one of the, you can say, most asked interview questions as well, like what are the fundamental of keys and why it is very much important. So the fundamental of keys plays a vital role in the data analytics databases, because when we try to keep our databases normalized, different tables will be created, right? And if there is no way to connect those two tables together, then it would be hard to do the data analytics or to perform any kind of database related operations. And that is the reason there are two main things with respect to the keys. First is primary key and second is the foreign key. So let's understand what is primary key. It is like a key element which we generate in front of each row, or you can say a combination of columns we can use from the table which we have created, and it is uniquely providing the identification to that particular record. Overall, what we can say, this is the mechanism or this is the keyword. Let's say we have a specific column in our table, for example employee ID. For each employee in an organization, they will be having a different unique identification numbers, right? Even two person having the same name, they might not be having the similar employee ID, right? So that is the same thing. It will help us to uniquely identify a record from a table. Second, you can see this is another table we have defined, and it is like employees. This table we defined for the offices, right? Here we are following same kind of integrity constraint, but another thing which I was talking about, the foreign key concept. So concept of foreign key is like, we can understand with a practical example, right? If somebody is visiting our country from different country, we call them foreigners, right? Because they are the primary citizens of their own country, but they are traveling in our country and just sort of reference. So same kind of concept, if we have more than one table and there is a key attribute which is a primary key of another table, and we are referring it into our table to establish that kind of connectivity which I was talking about. So in that case, we will be using this foreign key integrity constraint. So how to declare it? This is the syntax we can follow, like constraint name. So this is the integrity constraint. For each integrity constraint, we can provide a unique name, so that moving forward, if we want to add more integrity constraints, we want to alter it or we want to drop it, we can easily do that. So first we declare the name for this integrity constraint, then foreign key keyword. This column office code is something which we are referring in this employee table, and you can see in offices table, office code is a primary key, right? And that is what we are trying to establish. This kind of connectivity means references. So in employees table, office code is present here, and to establish that connectivity, we need to tell in this create table command that this column is present in which particular table as a primary key. That's what we have done here. So let's execute these commands one by one, and we will be able to see these two tables inside our database. So I have selected it, and as soon as I execute it, you can see this is successful. And if I just refresh it, then you can see one arrow sort of symbol has been created. And if I expand it, you can see offices table has been created. Now if I expand it further, right, you will see this thing, this option for the column. So here office code is there, city, phone, address line 1, address line 2, state, country, postal code, territory, everything has been created. All right, this is done. Now let's create this part as well. So I have executed this command. This table has also created, and if I refresh it, we can see employees, right? So if I expand it, all these columns have been created, and you can also see there is an option of foreign keys. So if I expand it, right, you can see this constraint which we created, right, employee IBFK underscore 2. That means this is something which is referring to the foreign key part. Cool. So we have created our tables. Now let's say we are inside particular database and we want to check how many tables are already there, and we just want to have a quick look at it whether table has been already created or not, then what command we can use? So command is very simple, show tables. Okay, if I write it in this way and if I execute it, right, you can see this is how we are getting our result. So employees and offices, if you have let's say 50, 100 tables, all will be listed down here in the form of output. All right, so now moving to the next one. So after creating the tables, we saw that how to get the list of these tables. Now let's say we have created a table and we want to delete it, right? So there are three things to understand with respect to deleting a table or deleting a data. So there is a main difference. When we talk about the deletion, either we can delete the data only or we can delete the entire table structure. So there are three commands, right, which are typically related to deleting the data or the table structure. First is drop table, second is truncate command, and third is a typical delete query. So when we talk about the drop tables command, what it does, it can delete a particular table completely, including the data and structure, right? And when we talk about the truncate table command, it will simply erase the data, it will not delete the structure of the table. And same goes for the delete command. Let's say we have some specific requirement to delete specific records from the table. So for example, let's say you have an employee data and now you want to remove all those employees from some specific location. You can put some filter condition and easily those records will be deleted from the table. So first let's try to run this one. Let's say we have created these two tables, right, which we can see. I will just quickly drop it. I will write a command to drop this table first, let's say the employees, right? So if I write the command, this is how it will look like, drop table and table name, right? And if I execute it, right, this is successful. Now in this left pan, right, you can see inside this tables now employees table is not present. All right, now if I do this thing, I apply the truncate command for the offices table. So this is how it will look like, truncate table and our table name is offices. So if I use it and if I run it, let's check whether the table structure will be deleted or not. And at this moment, since we haven't inserted any data as of now, so if I simply run this command, ideally nothing will happen because our table is still empty, but we will verify whether table structure is gonna be deleted or not. So if I execute it and run it, this command is successful, but you can see the office table is still there. That's the difference, and this is also one of the most important interview question, the difference between drop command and the truncate command. All right, so first let me bring back the employee table again. So if I select it and execute it and refresh it, my table is back. Cool. So far we have seen the basic steps. Now let's understand how to put some data inside a table. Okay, so you can see I have already created a template to insert some bulk data inside the employee table and similarly in the offices table. So nothing to worry about. If you want to follow all these steps, this whole execution step will be provided to you. You can find this piece of code which I am writing here or the SQL commands, the GitHub repository link will be provided in the description, and you can use all these commands as it is, whatever I have been writing here. So insert into then table name, and inside the parenthesis what we need to do, we need to provide the column sequence. So this is a typical syntax of inserting multiple records. So for an example, at this moment what I want to do, I just want to insert one single record. So how we can do it? So let me copy it from here and I will just paste it and will show you how we can simply insert one record and what is the actual meaning of this sort of bulk record. So this is the command we need to follow: insert into table name, and let's say you are pretty much clear about you need to insert data in all the columns. So in that case you can skip this part, that means defining the column names. You can completely skip this part, because if we don't put this column sequence, this insert statement will understand it like you want to insert data for all the columns. And after that we need to use this keyword named as values, and this is important. So see, when we talk about the table, and here you can see, right, this office table has also a proper structure, right? These column names are not randomly located anywhere. So while even inserting a particular record, we need to follow this sequence, okay? And that is the reason sometimes, let's say there are 50 columns in my table and I am supposed to insert the values for hardly 5 to 10 columns, right? So how to do it? Obviously we need to selectively provide the column names, and the column sequence which we are providing here, in the same sequence we need to insert the data as well. Else what will happen? We will get the exceptions of mismatch data type. Alright, so if I execute this command, and ideally it will insert this one record and we will evaluate it whether this is inserted or not. So let me select it, and if I run it, we can see. So as you see, when I executed this insert command, it is throwing an exception that cannot add or update a child row. And why is it happening? Because this is the first time we are trying to insert the data, and as we can see from the definition, this table, employee table, is actually referencing a column from this office table, right? So since this kind of constraint has been maintained, obviously the level of data insertion should be from parent toward the child. So in this case, what would be the parent table if we just consider this foreign key kind of relationship? Obviously the offices table. That means whatever values we are trying to refer in this employee table, first they should be available in the offices table. So instead of executing this command alone, first let me insert something related to this data, right? So first, I think I have clearly explained how we can insert one single record. You can just simply execute this command, and this is a variation of same insert command when we want to insert multiple records in one single insert statement. So in that case, what you need to do, only values keyword will be used once, and after that in the parenthesis what we need to do, we need to simply mention our column values, comma separated. No need to use this values keyword multiple times, just the records enclosed in the parenthesis. So first what I will do, I will quickly insert this entire data, and I selected it. As soon as I execute it, now we can see this insert is completely successful in the offices table. Now if I come back here and if I ignore this one single liner insert command and I directly try to execute this one, so we shouldn't be getting any kind of error now of inserting data in this table. So I have selected it, and as soon as I execute it, you can see this one is also successful. All right. So if I just refresh it one more time, and how to just get the preview of the data, let's say this is the amount of records we have inserted, how we can get the preview. Okay. So for this one, if I click on this thing, right, let's say employee table and the third option. So if I click on it, ideally we can see this is the preview of our data which we are getting. Ultimately it is running a select command, and I will specifically talk about this one as well. So don't worry about it at this moment. So this was about the preview. Now insert part is also done. We have inserted data in both of the tables. We will look other important commands in the SQL which is, let's say, alteration of the table, because there could be multiple scenarios where we want to change the data type of any particular existing column, or let's say we want to insert a new column, right? If we want to perform these kind of operation, in that case we need to follow this syntax, right? The alter keyword. Okay, so here let's say if we come back to our table structure, there is a column, let's say address line in the offices table, address line, and its length is 50, right? Its length is 50 at this moment. So what we can say, we want to run an alter command which will simply modify the data type or simply increase the length of existing address line 1 column from 50 to 100. So this is a modification in the table structure itself. So for that one we can use this alter command. So alter, and after that we need to mention the table name, which is the offices, and then our column name. So alter this one, and here what we are going to do, we are going to modify it, right? So modify keyword, alter offices, modify, and the column name is address line 1, and after that we simply need to mention the new data type. So this sort of thing can be implemented for other type of conversions as well. Let's say you have one column which is of integer type at this moment and you want to change it to the float or double, that kind of data type change we can also do it from here. So alter offices, modify address line 1, and the new data type will be varchar 100, right? And one keyword is missing, which is alter table, right? So the complete command is alter table offices, modify address line 1 varchar 100. So if I select it and if I execute it, we can see this is successful now. And if I click on it, if we come here and if I click on this column as well, okay, so how we can now identify it, that whether the data type has been changed or not. So for that one, so in order to see the complete structure of the table, what we can do, we can simply run this command, show create table and our table name. After that, what will happen, we will get the entire table structure, and if I execute it, right, we can see, let me just expand it so we can see the complete value. Now just focus on this part, you can see address line 1 has been changed to varchar 100. That is the thing which I wanted to showcase. Earlier when we created this table, its type was varchar 50, now it has been changed to varchar 100. So similarly, if we want to add a new column, for an example, so command is very simple, alter table offices, now add, and here we can mention a column name, right? Anything, let's say A, B, C or column 1, and just mention the data type, and after that simply selecting it, you can execute it and the new column will be added. So this is the syntax for that one. Now show create table we have seen the alteration of the tables as well. Now coming to the important part, which is to query the data which we have in our table. So in the beginning, when we started with the basics of SQL, right, we followed few sequence of the columns, right? So there are 3 categories of SQL commands as well, right? First is the data definition language, which is DDL. So data definition means any kind of SQL command which we are using and it is trying to directly, indirectly impacting the you can say structure of the table, right? Let's say we are creating it or dropping it. These are the things, these are the commands which are eventually affecting the structure of the table, and even including the alter command. So that is related to data definition language. Coming to the data manipulation, so insert command, update command, delete commands, these are the commands which are actually manipulating the data which is residing in the table. Third is the data query language, DQL, and DQL means where we are trying to select the data which is inside the table. So this is important because most of the things will be done with this one, like how we can get the few selected columns from our SQL table, and how we can rename it, how we can perform different operations, right? So quickly look at the examples of it. So here, let's say from a given table, if I want to select all the columns, so the command is select star from table. So here, if I mention offices and quickly I execute it, we can see we are getting all the records from our offices table, right? So in total we inserted 7, we have in total 7. Now let's say what we want to do, we want to simply get starting 2 records or 5 records. For that one, what we can do, we can use the limit keyword in our select operation, and after that we can put some numbers and only those number of records will be displayed in the output. If I select it and I execute it, you can see now only 1, 2, 3 records we can see in our output. Now let's say we only want to select few specific columns. So how we can do that? That is also pretty much simple. Just write those specific column names and that will become the part of our final output. So here let's say we want to display office code and city only. So office code comma separated second column city, right? And now if I execute this command, we can see only office code and city has been displayed in the output. Looking at the third aspect of it, which is important, so this thing, how to rename a particular column in the output. Okay, so if let me just run this one again so that I can see all the columns. So here let's say this is the postal code column, right? Normally we call it like a zip code or something. How to rename our columns in such a way? So for that one, the command is also very simple. So if I put it in this way, the second column is city and after that the third column is the postal code. So I will make it postal code as. So this as is the keyword which we need to use in order to give some specific name to any of the column or any derived column in the final output. So I will name it like a zip code, okay? And if I execute it, we can see this output where that postal code column has been changed to the zip code. Now another operation we will look at. So if I query this entire data of the offices table, right, we can see state, country, postal code, territory, all these things. So one of the common things, right, mostly when we talk about the data analytics, so let's say there are duplicate entries for any particular column in our table, then how we can get the distinct values out of it, right? So we have one important operation which we can use here, that is the distinct keyword on any specific column. So here in our data we can see country is something which has been repeated multiple times for different rows, USA, France, Japan, Australia, UK, right? So let's try to figure out if we have, let's say, lakhs of records, millions of records in our table and we want to just identify what are the distinct values in particular column, how to do that. So for that one we will use distinct keyword and after that just mention the column name. So select distinct country from offices and just execute it, and we can also rename it. As I mentioned about rename, I can name it like distinct countries. All right, so let me execute it. We selected it and execution done. We can see now this one, USA, France, Japan, Australia and UK. Earlier there were 3 entries for USA in the input table. Cool. So we have seen this thing. Now another cool aspect of this select command, which is the data analytics related, means how we can apply the inbuilt functions. Let's say we have our data, we have the table, how to apply inbuilt functions like count, min, max, sum, average, standard deviation. So all these things are already provided in the SQL library. We simply need to use it on the respective columns. So I am going to write a select command which will calculate something, right, on the specific columns. Let's say finding the maximum, finding the minimum, and for that one what I am going to do, I am going to use the employee table. So select star from, you can say, the employees table, and let's look at what data we have. So after selecting it, we can see this is the data, and this employee number is something which is of integer type. So definitely if there are numerical data types, we can apply count function on that one. Not just count function on numerical data types. Count is something which will help to count different type of things. Let's say how many rows are there, distinct count for the column values. But other operations like sum, min, max, average, standard deviation, this is something which can be only applied on numerical data types, not string sort of things or the date type kind of things, correct? So select star from employees. Here I am going to use employee number to write a select statement where I am going to do different operation. First, let's say I want to count the total number of rows which are present in our table. How we can do that? We can use this thing count star, and I can give a name to it, total rows. This one will calculate the total number of rows available in my table. Second one, let's say I want to find, because here you can see, right, these are the integer values 1002 numerical values. So if I randomly try to identify what is the minimum value, maximum value, I can definitely do that. So for that one I am going to use, let's say, this min function, and I will pass the respective column name, which is employee number, and similarly I will name it like min emp num. And if I want to identify the maximum employee number we have assigned so far, I can change it to max, and it will be also renamed to max. Similarly, if you have another column, right, the example you can take here, the salary column in the employee table, somebody asks you to identify total salary a company is paying to their employees, right? You need to apply the sum function, and similarly you need to identify the average salary of the employees within the organization. You can simply apply the average function, right? All those kind of calculations will be done very easily. So this one we have already did from employees, and if I execute it simply, right, we can see total number of rows, total number of records we inserted 23, minimum employee ID number was 1002, maximum 1702. So this is how inbuilt functions we can apply on different columns in the SQL table. Cool. So when we talk about the final output or performing the select queries, sometimes what we want as an end user, we want our data to be organized in some specific column names, maybe ascending, descending. So how to do that in the SQL? For that one we will be using the order by clause. Order by clause, we can provide multiple comma separated values and their respective arrangement, let's say ascending, let's say descending, all those things can be done. So if I display our employee data one more time, we can see this is the data and how we can arrange it. So here if you look at the office code, right, so office code is something which is randomly, right, let's say 1 2 in between 4, then 7, then 6, then 5, then 4. Okay, so one arrangement can be done on this one office code in the ascending order. This is number one. And another one can be done, for an example, the reports to, right? Reports to is basically the manager ID here, and manager is an employee itself, so this ID is eventually belonging to these number here. So this is how we can arrange our data. So let's see how to do that. First I will only apply this output on the reports to, not only reports to basically the office code column. So select star from employees, order by keyword office code, right? So if we execute it, then let's see what happens, what output we'll get. So here now you can see it is properly arranged for us. 1 1 1 1, these kind of values are together, 2, then 3, then 4, then 5, then 6, then 7. So by default, when we apply the order by clause, it arranges our data in the ascending manner. So if we want to arrange this data in the descending order, what we can do, we can explicitly mention this DESC keyword, and now if I execute it, this whole arrangement will be done in the descending order of the office code, which we can see here. Now if we want to apply multiple level of ordering as well, so I'll give you an example how it can happen. Let's say you have employees from different companies, and you want to arrange first your data in the form of the ascending order of country codes, okay, or you can say simply countries. So any country which is starting from, let's say, letter A, if you talk about the lexicographical order, those will be on the top, then starting from B, C, and so on. And there will be records which will be duplicated, and multiple duplicacy there will be, like the USA related records multiple time. And within that particular section, right, the chunk which has been created for USA employees, you want to arrange the data in the descending order of salary. So what kind of command you can follow here? I can show you the placeholder for that one. So select star employees, order by, let's say, country, and comma, second is the salary, which is in the descending. So first what it will do, it will try to arrange the records in the ascending order of country, and if our SQL engine sees that there are duplicated records for the country, within that it will just arrange the data in the descending order of salary. So that is how it is going to work here. Okay, so now we will see how to filter the data set. If we have created our tables, how we can write that particular syntax which will give us some specific result in our output, and that is being called as our data filtration, or the filter logic, or filter clause you can say, but its technical word is where clause. And I will show you how we can apply selective operations like and or operation, like, in, is null, is not null, and there can be multiple ways we want to query our data with some specific conditions, right? So if we look at our employee data here, you can see multiple ways we can select the specific chunk of data, and that is the condition we need to mention. So for an example, here we can see office codes, right, and in each office, right, different folks from different designations are also working, right? So if we want to do some kind of selective search, it is easily doable. So let me write it in the way we can query the data. If we want to relate here, we can see reports to is something which is sort of a manager ID. So here we can see this employee whose employee number is 1501. He is actually reporting to 1102. So let's look at who is 1102 here. You can see Bonder Gerard is the employee who is the manager of this employee 1501, and its name is Larry Bot. Okay. So in the same way, right, a manager can manage multiple employees, right? So we want to query all those employees who are reporting to employee code 1102, or we can say Gerard. Okay. So select star from employees where, this is the keyword we need to use, where reports to, and we need to check what was the data type of this column as well. So here if we come back and we check, the data type of reports to is actually of integer type, right? So we can simply mention it as it is, because if it was, let's say, of a string type, we need to mention it in a different way. So reports to equals to, this is basically a equality comparison, 1 1 0 2. Okay, so this is the filter condition we have applied. We are trying to identify all those reports, we are trying to identify all those employees who are reporting to 1102. Now if I select it and if I execute it, we can see, right, this is the list of all such employees who are directly reporting to 1102. So this is the one simple where clause implementation we have seen here. Now let's discuss what could be the syntax where we want to concatenate multiple conditions together, and that can be any logical condition, and kind of condition, or kind of condition. So let's try to do that, and for that one we will again look at our employee data, and we can see, right, these are the things which we can use for our practice multiple conditions. So here I'm going to apply this condition. First let me display the entire data set here. So if I execute it, this is the entire data set. Now let's try to check what we can use for our AND part. So we can see multiple designations like president, VP of sales, VP of marketing, right, sales representative. So here specifically if we look at this thing, the sales manager and sales representative, and these two people who are having these respective designations are working in office code 1. Office code 1 eventually having multiple designation folks, correct? So let's say if we want to filter out these records, so select star from employees where office code and the office code data type is varchar, right? So what we need to do, we need to put it in this way, enclosed in the double quotes or single quotes, so that it will act like a string. So office code 1, and another condition, let's say from office code 1 we want to identify the employee number, name, etc, who is having a designation of VP sales, right? So second will be on job title equals to VP sales. Okay, here we can see VP sales. Now if I want to execute it, this is how it will look like. Okay, we can see this record only which we wanted to bring in our output, 1056 Mary Patterson actually working as a VP of sales in office code 1. So this is a AND condition. Okay, now if we want to apply the OR condition, okay, so how we can do that? Let's say if I display the entire data, there are two things. Here what we can do, either print the data of office code 1 or print the data of all such employees who are working as a sales representative. Let's say if we want to apply this kind of condition, how we can do that? We can use this similar thing here and we can just apply the OR condition. So OR job title as sales, REP means representative, and now if I execute it, so easily we will get the records for the office code 1, or if any sales representative, right, who is having this job title will be in our final output. So if we have executed it, right, we can see the records from the office code 1 are definitely included, and from other office codes we are only getting the data of job title sales representative. And why it happened? Because of this or kind of condition. Okay, so this is the another version, or now we will look at the how we can apply these kind of operations as well, right? Like this is another way of filtering the records based on some string pattern searching, right? Like, in, is null, is not null. Okay, so one by one we will also check it. So this like operation can be done only on the string based or string type of data types. So select star from employees, where what we want to do, where we want to filter out all those kind of employees who are having a job title starting with sales. It can be sales manager, sales VP, sales representative. But what we want, we simply want all those job title employees whose designation is starting with sales, right? So how we can use this operation? Select star from employee, where job title equals to, where job title like. So this is the keyword we can use, and in the single parenthesis we need to apply that pattern matching. So that pattern matching is eventually related to this thing. Means ideally it should start from the sales, after that it can be anything. So there are two wildcard characters which we can use. One is the underscore sign, another is the percentage sign. So when we apply this thing, percentage sign, after any of the string which we have written inside this parenthesis, so this percentage actually means 0 or more characters. So doesn't matter whatever is written after the sales, right? Let's say we can see sales manager NA representative, right? It will just look at in this way, that this designation is starting from sales, and after that whatever is written, I will simply pick this one. So that is how SQL engine will decide it. And now if I run it and if I execute it, right? So in our output we can easily see the data which is just related to the job titles which are starting from sales, nothing apart from that one. So this is also one of the important keyword we can say, or important operation in the where clauses. So this is the sales related, and now try to imagine multiple scenarios where you just want to pick the record. For an example, you have a data for different states and there is one column named as feedback or comments, and you want to search only those records where in the feedback some specific keyword is mentioned. So when there is a long text and you are not even sure whether that particular keyword might lie, so what we can do, we can put percentage before as well, and whatever text we want to identify, that should be in the middle, and after that we can also put the percentage. So how it will look like? Sales anywhere in the particular string column value, and before that whatever words are there doesn't matter. After the sales keyword, whatever words and characters are there doesn't matter. So for the example of that wildcard character which is underscore, let's try to implement a condition where all those employee names, or you can say employee records, we want to fetch whose first name is having only 4 characters. If this kind of condition we want to apply, so we are trying to strict something, we are trying to apply some strict condition on the characters present inside the first name. So here we will replace it as first name, and it will be like underscore 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 4 times. So one underscore represents one character here. So in this case, this filter condition will try to check that what are the employee records where this pattern is exactly matching with first name. So if we give a quick view here, we can see name starting with Mary, Jeff, right, and Louis, after that Mami, right, Andy. These are the names which are having only 4 characters. So ideally these kind of records we should get in our output. So if I just select it and execute it, you can see these were the records which I was talking about we are getting in our output. So next one is related to the in operator. So in operator is just like a lookup kind of thing. So when we try to write those kind of queries where in the filter, or you can say where clause, we want to verify that something is specific to these particular values, we are getting the output in our final result or not. So in this case we want to apply lookup related query, and for that one we can use this in operation. So select star from this table, and here what I am trying to do, I want to just bring the data for the two office codes, let's say 1 and 6. So how we can write this query, where office code in 1 comma, I have also mentioned 6. So now you can see this will be acting like a lookup query. In this parenthesis I have mentioned only those values which will be used to evaluate the lookup part, because in our office codes we have seen different office codes are there, let's say 1, 4, 6, 7, and in this way when we will write this query, all the records will be scanned, and wherever the office code value is matching either with this one, either with this one, that record will be captured for the final result. So now if I just execute this one, and in our output we can see we are getting the data only for office code 1 and 6. After that, if I again present this data in front of this screen, and here you will see there are few records, right, or let's say this record itself which is having the null value. Okay, and I think for this example we should use the office data because there are multiple null values present. So if I write this query and we look at the office data again, so offices, and here is the query, and we can see multiple null values here. So that is something, if we want to fetch all those kind of records, and this is also a very important step in the data analytics, data cleaning and cleansing part, where we try to identify all such records who are having garbage, null type of values, we want to discard those things. So how to actually identify it? For that one we can use is null, is not null. Is null will be based on the filter condition, where we want to check if this particular column is holding null value or not, and is not null is just a negation of that previous condition. So select, here we can see, let's say we want to identify all those records where the value of state is null. So how we can apply this condition? Select star from offices where state is null. Simple, this keyword we can apply here, and now if I execute it, in our output we can see these are the records or office codes where state value is not populated. And if we do just the reverse of it, that is also doable, and if I apply is not null, so we should be getting all those records where value of state is populated. So this is a very helpful thing when it comes to deal with the null related values in the table. So far we have covered most of the important steps, but still few things which are left, and that is the important part of the SQL commands. Like we have the data in the table, how we can update particular column values based on specific conditions. So let's try to have a look at it, how to apply the update command in SQL. And for that one I will query the full data of employee and will figure out the specific conditions for it. So if I select it and if I execute it, so here we can see this thing. So let's say what we want to do, we want to change the job title of this sales rep to proper name, right? Sales representative. We want to change this entire thing. So what we can do, we can write a simple update command and it will be done in just one single step. So what's the syntax for it? Update which table we want to update, right? Update employees table, and what we want to do, we want to set some value to this particular column. So update employees, set job title equals to this new title, which is just a complete abbreviation for the sales rep representative. And how this update command will identify how many records I need to update, right? Let's say there is a need of updating the entire value. For an example, you want to just give the same designation to all the employees. You can even do it without any where clause, because at this moment if I execute this command, it will simply update or it will replace the designation or the job title with this value, but we need to do it selectively. So how we can do it? We can mention the where condition, that is specific condition where the update will be applied. So update employees, set job titles equals to this, where job title equals to sales rep. So how this command is actually working? First, it will apply the where clause. It will identify all those employees where job title is sales space rep, and after that it will simply reset that value to sales representative. Now if I just execute this thing, so here we can see that it is throwing an exception that you are using safe update mode. So this is actually a safety feature in the SQL workbench, because these update command is something which is actually related to some changes, and easily this can violate the safety feature unnecessarily. If somebody is trying to update the values, it can create the inconsistency in the table itself, right? So by default this safe feature is set to false, means if we don't turn it off, then we won't be able to update the records. And if we want to do that, we need to mention some primary keys. So first let's try to execute a command here, how we can just turn it off. For this one, SQL safe updates, this is the command we need to use, and we need to set it 0. And now if I run it, okay, this has been executed. So ideally after this option, if we try to run this update command, we should be able to do that, and that's had exactly happened here. We can see this is successful. And now if I query the data from this table, the employee table, select star from employees, so we should get the updated data now. So here we can see this name, which was previously sales rep, has been changed to sales representative. So similarly, this is how we can keep on performing these kind of update operations. Now looking at the delete command. So if you remember in the beginning, I mentioned about the drop command, I mentioned about the truncate, and there was one other way where we can do selective delete from our table with the help of this delete command. So for that one, how we can do it? What's the keyword we should use here? So for an example, from this table, we want to delete all the records for the office code 1. This is something which we want to do, and we want to remove all the employee records which belongs to office code 1. So for that one, what kind of query we can write? So delete from employees, delete from employees where office code equals to 1. And if we execute this query, we can see this has been successfully executed. And now if I query this data again, there should not be any single record even related to office code 1, which we can easily see here. So that is how we can use the delete command to delete some specific rows from our input table. And same way we are using where clause, you can concatenate multiple conditions based on your need, what kind of the condition you want to use to delete any specific record. So now we will be looking at the most important operation, which is the group by, because when it comes to the data analytics, mean, median, mode, sum, average, this is fine, but we need to perform these kind of operations on some specific column values, right? And that is the very important part in the data analytics, and this group by operation is something which plays a vital role in order to perform these operations, because in this way we can granularize our data, we can granularize our output. Let's say we have our data from the e-commerce website where in a day millions of transactions are happening, and those transactions are happening from across the globe. So if you want to just identify from which country how much sale has happened for today, you just need to categorize this data. You need to create these smaller blocks, smaller chunks, so that you can apply that kind of average, sum, min, max, count related operations on that particular distinct values, and you can granularize your analytics. And for that one we can use the group by clause in the SQL. So what is the syntax here? And first let's understand what example we will be solving here. So we can see, right, different office code values in our employee table. Now let's say if your management team comes to you and they ask you to give this analytics to them for each office, or let's say within each office how many employees are actually working. All right, so how we can perform this query? We can write it in this particular form. So I actually need to tell you one very important point, and that is why I'm not putting any column in the select operation at this moment. I want to complete the group by statement first, and then I'll tell you what is the catch with the group by operation. So leave it as it is. Now select from employees table. After that we will be writing this group by operation. So select from employees, group by office code. We actually want to perform the group by operation on the office code column. That's why we have mentioned it here, and this part is done. So when we talk about the group by operation, in the final select statement we can only use those columns in the final select statement which are part of group by keyword itself. Apart from that, whatever columns will be left, they can only be used with the aggregation operations like count, min, max, average. If we simply want to, let's say, select this thing, office code, and apart from that I simply write job title, so this will definitely throw an exception. Let me execute it. Right, we can see this is failing expression here, because the reason which I explained, the columns which are present here, this is actually not the part of group by keyword itself. So let's say if I'm using job title or any other operation, I definitely need to put it in the some kind of aggregation functions like min, max, and all these kind of things. So here the main problem statement was to count the employees in each office. That's why we did a group by on office code. After that we simply want to apply this count function, right, normal count function if we are doing it, okay, and we will name it employees in each office. This is the derivation we are doing, and now if I execute it, all right, we can simply see this output. In office code 2, 2 employees are working, in office 3, 2 employees are working, in office 4, 5 employees are working, and so on. So this is the group by part, and it can be used with multiple things, and I can show you another alternative of it. If we want to group by on more than one columns, whether that is doable or not, exactly it is doable. So let's figure out what kind of columns we can actually use here for this sort of grouping. So for this example, we can see this office code and reports to. So see, manager is an employee of a company, and when you are a global company, what will happen? Different employees are working from different locations, and one manager which might be present in a different location can manage all those employees who are working from different regions. So that is the same kind of metrics we can see here. So this employee 1504, 1501, right, their office locations are different, right, 1370, but their reporting manager is same, 1102. So how we can write a query that for one specific manager, if I want to see how many employees are working from different regions, means the grouping on the this level means the reports to, and this is the exercise we want to do for all of the managers, right? So if we want to do it, how we can apply this kind of multi-column grouping. So here our problem statement is we want to group it first on the manager ID basis. Within the manager ID basis, we want to group it on the office code level, and then we are counting the values. So here it is office code in the group by keyword, and after that we are mentioning, first we need to mention this reports to, and after that we need to mention this part which is office code, reports to, comma, office code. Now here what need mention here, reports to office code. Office code, and after this one the value which we have derived, that is absolutely fine, employees in each office. And now if we execute this query, right, we have got this output where we can see for, let's say, this 1102. So even the manager 1143 is also managing employees from different regions. So that is how we can see the multi grouping can be done. Now let's look at the example where, let's say, we have created a chunk, means different groups, and after calculating the values in the group by operation, we want to filter out something, right? We want to filter out those kind of chunks where they are not following any specific condition. So along with the group by clause, we can use having clause as well. And having clause doesn't have any individual identity. It cannot act like a where clause, which is where clause when we talk about, it is actually like a independent entity. But this having clause can only be used along with the group by, not individually. So let's try to write some query where we are performing some operation, right? Here we can see our entire data set. So what kind of query we can apply? So let's say we are trying to calculate the strength of the employees in each office, and we are only interested in these offices where the strength of the employees is more than 3 or equivalent to 3, not less than that one. Okay. So how we can write this particular query? If I paste it here, this part which we have already written above, and here we will simply apply this condition. Okay, we are only interested in these kind of records. So here this query will be exactly same, office code grouping we have done. After that we are counting the number of employees for each office code. But here what we can do, after this group by operation, we can write this having keyword and we can apply this condition. Count star means whatever count which has been calculated for one individual group, we are checking its value whether it is matching with our threshold value or not. That is count star greater than equals to 3. Okay, this is the thing which we wanted to evaluate. Now if I run this query, okay, here we can see only 2 office codes, 4 and 6, because these are the offices where employee strength is equivalent or more than 3. So now let's look at the last operation of our tutorial video, which is also the most important, the very important, the joins. So why joins are actually important? As I already mentioned in the beginning, the fundamentals of the keys, primary keys, foreign keys, because data analytics is not only about one table where you have everything and you are doing everything. It is always about creating a normalized database, and that will definitely have multiple tables. So we will be having multiple ways, different logics, different conditions to bring data together so that final informative report can be generated. Okay, so that is why this join operation is something which will be very helpful, and there are different type of joins available. The most important ones are like inner join, left join, right join, also full outer join. So one by one, first I will explain how inner join works. So if we go back and try to just display the output for employee and the offices table. So select star employees. Okay, here if we look at this data, we can see office code which was of a string type, right? These values are present here. Now if I query this data, the offices, so here we will also see the full detail for each office based on the office code column, right? So definitely this office code is the important column based on which we can join these two data sets together. So first type is the inner join. Inner join means when we are using few key attributes for the join operation, so in the final results only those records will be present which are having the same values. If there is any mismatch for the values, those will not be included in the final result. So if you just want to imagine a Venn diagram for it, if you have two sets of number, so whatever will be the overlapped part or the middle part, that is the section we will be getting in the inner join output. So let's try to write the query for it, how we write the proper syntax to perform the join operation. So here what we are going to do, we are going to involve two tables, and there is a concept of giving alias name to the tables as well. How we can do that and why it is important? Because in the final select statement, we might be interested in few selected columns from table A, table B. So we should have some reference name or alias name which can be used here. So let's say employee table, we will give a alias name like EMP, and for offices table we will give a alias name OFC. Okay, so that is why first I am writing the complete inner join part, and at the end I will be writing the columns in the select statement. So select from employees table, and the alias name is like EMP, just one single space, and after that whatever you are mentioning in front of the table name, that will be treated as a alias name. So from employees EMP, inner join offices OFC, and after that we need to mention this on keyword, because when we are joining the two data sets, we need to mention which column we are going to use. Okay, and for this one, from the EMP table, there we also have a office code column, and we also have this column in the offices table. Okay, so the same column, you can see we are trying to join these two tables with the help of office code column, and even this is not necessary that column name should be same. Column names can be also different, but with the proper aliasing name we need to provide this referencing that in which table these two columns are present. So this is the condition for inner join, and as I said, now I will mention proper column names. So here what we want to do, we want to select all the columns from the employee table. So it will be EMP dot star comma OFC dot start. Okay, now you can see this is the complete statement or syntax for our inner join. Now if I execute it, okay, in our output you can see there is a very big table which is involving all the columns from both of the tables, because we have done this kind of select emp dot star ofc dot star. But the interesting thing we can see office code, right, the output which we are getting in our final result, the values for office code 2, 4, 5, 6, 7 is present, right. If you remember, in our office code table itself there was a code for 1, value 1, means there was one office where the code was assigned as 1, but for that particular code there was no record in our employee table. Here, using the delete command, we deleted all those employees who were belonging to office code 1, and that is the thing which I want to highlight, that if we perform the inner join, those kind of records will not come in the final output. Now talking about the left join, this is also another version of this inner join kind of thing. So here what will happen, again try to imagine the same Venn diagram, two data sets, and if you are using some on condition and there is a table which is on the left side, when we perform the join operation there will be a table on the right hand side. In case of left join, whatever records are getting matched properly, they will definitely become the part of final output. But let's say there is any specific value which is present in left hand side table, but there is no specific match for that one in the right hand side table, then in that case we will be getting the output from the right hand side table, but those values will be populated as null. Okay, so how we can change our query? Simply we need to change this keyword from inner to left. All right, so if we execute it, right, we are getting the data. But if you remember, in our employee table ultimately there were all such type of records for which match is definitely present in the office code table, right. So for an example, if we try to explicitly insert few records in the employee table which are not present in the office code, let's say office code 2030, we are maintaining entry in the employee table but those are not present in the office code, then this left join will give us the output, but the right hand side table column will not be populated. They will always be populated as null. Now if we talk about the last operation, which is the right join, for that one you can just treat it like a reverse of left join. So whatever thing were happening with the left hand side table in the left join, same thing will happen with the right hand side table in case of right join. So if there is a match, obviously those records will become the part of final output, but if there is a mismatch, then the records from the right hand side table will be there, they will be completely populated, but the records from the left hand side table will not be populated because there was no match available for that value. So how we can do that one? If I write this left to right and if I execute it, in this case we can see this one, this record is something which you need to focus on, because since we deleted all the employee records which were belonging to office code 1, that was the reason in employee table there was no employee record related to office code 1, but this entry is present in the offices table and we are doing a right join. So this is the right hand side section which is coming from offices table. It is completely populated, right? You can see this is completely populated, but the data which is coming from the left hand side table, this is completely null. And why it happened? Because there was no match for office code 1. So that's what I had for all the SQL basics command, and I'm pretty sure this practical implementation will give you the crisp idea how to set up this whole MySQL environment in the local machine system and how to perform all these basic operations with the dummy data. And as I said in the beginning, this entire code piece will be provided to you in the GitHub repository. You can find the link in the description and you can also practice the same things. So that's what I had for this video. I'm pretty sure now you have a clear idea how to use and apply basic SQL commands, and the code snippet and the queries which I was writing, you can also use it and try to implement it practically. The GitHub repository link will be provided in the video description. And if you find this video informative, then hit the like button, and if you have any doubts, any queries, then feel free to put it in the comment section, and don't forget to subscribe Scaler's YouTube channel for more such insightful content.